Now, it may seem kind of funny to talk about curvilinear effects in the same time we're talking about interactions, but as we're about to see, curvilinear effects are mathematically the interaction of a variable with itself. We look at it, well, we'll see just a sec. You can think of, with a curvilinear effect, you have a continuous variable where the effect is U-shaped. And it might be a right side up U, it might be an upside down shaped U. You can think of it's often, where we often see this, is where there's, whatever your independent variable is, there's some optimal level of whatever your continuous variable is relative to your outcome. This was my dissertation was looking at parental control and adolescent behavior problems. And there was an optimal level of even what we think of as kind of negative coercive control. There's an optimal level that it kind of, with inner city kids, with urban kids, that you'd see it was like a right side up U that too little and kids' behavior increased, too much and kids' behavior and problems increased. But there's kind of just the right amount, that optimal, kind of an optimal zone. And you can see that in all sorts of things. Probably studying. You might think, there's probably an optimal level of studying. But that might be an upside down U. If I never study, my grades are low. As I study more and more, my grades get up and up. But at some point, I'm studying nonstop, I'm not getting any sleep, I'm not eating, I'm really stressing out. Your grades are probably going to go down again. So you might think of studying as something where there's an optimal level. But that's, if you're doing research or you're kind of thinking about your thesis, dissertation, whatever, and you find yourself thinking that, well, there's probably a sweet spot, a perfect level, or that, start thinking in terms of maybe I should test the curvilinear effect. Don't just test a straight line, because if you may completely miss it. If it's a U like this, and you don't include a curvilinear effect, your regression line is going to be a flat, perfectly straight 0 right through the cloud of the scores, and you're going to completely miss the boat. It can also reflect, these curvilinear effects can also reflect where there's a plateauing effect or a leveling off. And even though mathematically, because this multiple regression requires a linear, one of the assumptions of multiple regression is that you can write it as a linear regression equation. What we've got, even with the squared terms in that, even if it's making a U-shaped, it can still be written as a linear equation. That means I'm writing y equals something times something plus something times something plus something times something plus something times something. But in the end, it's all equal to y. And because of that, it's impossible, it's impossible to have an effect that says, that comes down, 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 and then levels off. Or it's like this. Maybe my intervention has no effect, no effect, no effect, and then it starts to have an effect. Regression, multiple regression, can't do this leveling off, can't do a plateau. It can go U, but it can't go curvy and then flat, dead line, flat line. It has to go back up. It's just the math. It can't, even if in reality it's flat, it will have a little kick up. Example, years ago, I wish I'd actually contacted the authors and done like a reanalysis of their data or something. There was a study, I think Chapin knows what I'm talking. There was a study came out looking at drug use and teenagers. And their conclusion, they tested it, they thought that there might be some curvilinear effect, right? That, some level is not going to hurt you, and then, some experiment. And sure enough, they did the study, and they found it was U-shaped. That high levels of drug use had all sorts of negative outcomes on kids, and it came down. It plateaued at just a little bit of drug use, and then the curve kicked up again. And I have never seen hippie liberal professors so excited over, see, drugs are good for you. A little bit of drugs are great.
I know who you're talking about.
It was just kind of funny. It's like, oh, come on. And because then they pointed to, oh, see, it's U-shaped. It didn't flatten out. It ticked up at the end, which shows the kids who did no abstinence, those kids who were abstinent, actually, it was bad for them. It's best to do a little bit of experimentation. They had all these rationalizations of why that it's this strict, repressive, Republican, Christian, whatever sort of culture that's keeping these kids down, and they need to do a little experimentation, and that's optimal. I would say it's the math. It has to tick up. It can't. If it's plateauing, and which I think is much more believable, a little bit of drug use isn't going to kill kids, But this notion that the curve came back up, it's the math. It has to come back up. The sky is blue, the grass is green. You cannot plateau out with multiple regression. You have to do nonlinear regression, which is something else, if you want to go that route. But it was just funny because people were so excited over this tiny little uptick. So anyway, I digress. But that's a good point, thing to keep in mind, that when you'll see it, it may be, and you may see that it kind of starts to dip a little bit. It's kind of curvy, and then it dips a little bit at the end, or it's dipping a little bit, and then it's... I think often what that is it's not that it's curvilinear down here, it's just flat, and then it's taking off. It's a plateau, and then it takes off. But you can use curvilinear regression to detect those. Just don't get all excited when you see a little uptick at the end. Think about, is this just a plateau effect at that end? You can see kind of here's the example I talked about earlier, that you can have this optimal level. You can actually do the calculus, if you want, and calculate exactly what that optimal level is, exactly how much of whatever you need is the perfect amount. It can be a plateau, like we're just talking about. This would be a case where it's probably just, it may very well just be leveling off on here. You probably don't have the statistical power to actually reliably detect a little dip like this. It's probably just leveling off. Okay, let's go through an example. We'll stick with our good old reliable college GPA, working hours, and in this case, sex. I honestly can't remember. I'm not going to center this one, I don't think. Well, we'll see in just a minute. I don't think I centered the data on this one. So we're going to make, just to keep it separate, so we're looking at work is 0 to 40 hours. Now, to make your curvilinear effect, all you do, when we did I thought you were signaling me to, I was running out of time.
Well, you kind of.
We're not going to finish, but we'll get close. So for a curvilinear effect, how you make it is you take your variable, your continuous variable, and square it. Multiply it by itself. In that sense, that's what I say. It's kind of an interaction with itself. Instead of work times sex or work times anxiety, it's work times work. That's how you make these cool curves. So I'm going to make a new variable called work2, which is just work times work. I'm going into this kind of thinking that work will have a negative effect on grades, but it may plateau at some point. I think that makes sense. The little bit's not, is a little bit going to have the same effect as a lot. Below a certain number of hours, it really doesn't make a difference a little bit. Okay? So now we're looking at college GPA. It's kind of a new example. We got 603 now college students. Females we're going to enter our sex variable, female, coded 0, 1. Males are 0, females are 1. We're going to then enter work, and then we're going to enter work squared in the second step, in the third step. So we're kind of approaching it step by step. To test just like we needed to test the interaction kind of all on its own and see what's the change in R squared or that, we need to enter the curvilinear effect on its own so that you need to somehow isolate it. If it's only one variable, you could just do a simultaneous regression because this is just one, and look at the regression coefficient for the squared term. It'll give you the same answer, but it's nice just to run them separately. I think it's just clean. It doesn't take any additional computer time or microseconds. Here's our model. With everything in the model, so here's when we added female, that was significant. Here's where we added work, it was still significant. When we add the work squared, right, the square term, work 2, it's still significant, very significant. 3 and 599 degrees of freedom is, our F is 195.6, P is less than 0.001. The total model, including the quadratic, just the square term quadratic, it'll slip out of my mouth. Well, also too, when you're reading, people talk about a quadratic term, that's what they mean, from like high school geometry. The square term is your quadratic term. So the model, including work squared, our quadratic curvilinear effect for work, accounts for 49.5% of the variance. The quadratic term, that curvilinear effect, accounts for 2.5% of the variance. And again, we talked about that this is when you're looking, just like with interactions, curvilinear effects may account for, the variance may not seem very large, but it may still be a substantive effect, kind of for the exact same sort of reasons. So, you need to, don't look at these and think, oh, that's 1% of the variance. I thought that was no big deal, so I'm not going to worry about this. Again, always graph it and see what the data are showing you. That 2.5% of the variance is highly significant with 1 and 599 degrees of freedom. Our F was 29.272. P is less than 0.001. Here's our regression equation. We can write it all out. Notice I've gone to extra decimal places because it's just, if you go to, it's just too small because you're squaring 40 hours a week squared is a big number. So, like we said, the quadratic terms, the regression coefficients can get pretty small, again, based on the scaling. So I've just kind of expanded it out a little bit.